Close your eyes for a moment and imagine drifting through something ancient, vast, and full of stars. You're not outside of it, you're inside it. Tonight, you won't just learn about the Milky Way. You'll float through it, through stardust and gravity, mystery and memory. Not to chase facts, but to fall asleep inside them. Let this soft cosmic sea rock you gently, one whispered truth at a time. And if you're still awake in a few minutes, drop a little good night in the comments, or tell me from which country you're watching. I love seeing our sleepy constellation grow, one quiet soul at a time. Number 1. When you look up at a clear night sky, the soft glow you see crossing the stars is more than just beauty. It's a side view of our own galaxy, a flattened spiral of light, gas, and dust that we are floating inside. And though it seems still, it's alive with movement, motion, and quiet memory. That faint band across the dark is a reminder that we are not outside the story. We are deep inside it. Number 2. The Milky Way has collided with other galaxies before, and it will again. We often think of galaxies as still and settled, but they are not. Over billions of years, our galaxy has absorbed others, unraveling them like threads and weaving them into its structure. It's happening even now, and someday we will merge with Andromeda. The sky will change, the stars will shift, and the galaxy will become something new. Number 3. Not all stars in our galaxy were born here. Some are older than the Milky Way itself. Halo stars, drifting high above the disk, move on tilted paths that suggest they came from somewhere else. Their chemistry is ancient, their motion is slow, and in them we see the fingerprint of a time before our spiral arms even existed. They are elder spirits, fossils of light from a younger universe. Number 4. Right now, our solar system is spinning around the galactic center at over 800,000 kilometers per hour. And yet, it takes about 225 million years to complete one loop. That journey, a galactic year, means that when dinosaurs walked the Earth, we were in a completely different part of the galaxy. The stars change. The sky rewrites itself, even as we sleep. Number 5. Although the Milky Way is old, it is not finished. It's still growing. Gas from intergalactic space drifts inward. Small galaxies are captured and torn apart. And through this quiet accumulation, the structure deepens. We live inside a galaxy that is still under construction. A slow, stellar mosaic, stitching together the ruins of 1,000 smaller worlds. Number 6. You might think we know how many spiral arms our galaxy has. But from deep inside the disk, it's hard to tell. Dust hides distant stars. Starlight blends. For decades, we believed there were 4 major arms. Now, it seems more complicated. Some arms split, some fade, some may not be arms at all. The Milky Way is less like a pinwheel, and more like a living swirl of stars, shaped by time. Number 7. Most stars follow calm orbits, but a rare few are flung from the core at astonishing speeds. These are hypervelocity stars, launched like glowing arrows. Often, they were part of binary systems, 2 stars orbiting one another, until one was swallowed by the central black hole. The other escaped, hurled out of the galaxy. These lonely travelers drift through the dark with no path back home. Number 8. Look high above the horizon, and you'll find a ghostly smudge, the Andromeda Galaxy. Though it lies over 2 million light-years away, it is slowly drifting toward us. In 4 billion years, it will merge with our Milky Way, not as a crash, but as a dance. The stars won't collide, but their galaxies will fold into each other, shaping something new. An elegant, timeless merging of two massive spirals. Number 9. Most stars orbit the center of the Milky Way in the same direction, but not all. Some, especially in the galactic halo, move in retrograde, backward. These stars may be the remnants of ancient galaxies absorbed long ago. Their orbits are stories, ghost loops that spin against the flow. Like memory itself, not erased, just traveling in the opposite direction. Number 10. The Milky Way has devoured dozens of smaller galaxies. We see the evidence in the chemical makeup and motion of certain stars. The Gaia-Enceladus merger, for example, brought waves of stars into our system and may have reshaped our early structure. This is not a pristine galaxy. It's a layered one, built from pieces, quiet mergers, ancient visitors, and the stars that stayed behind. Number 11. Every star has a chemical fingerprint. Its light carries information about what it's made of: carbon, iron, helium, and more. Some stars are rich in heavy elements, formed in dense, enriched clouds. Others are nearly pure hydrogen, born just after the universe began. By studying this starlight, astronomers can read ancient history. Each atom is like a word. Each star, a line of poetry written across time. Number 12. If you could look closely at the sky, you'd see streams of stars, thin glowing rivers across space. These are stellar streams, the remnants of small galaxies the Milky Way has torn apart. Their stars stretch in long, graceful arcs. Some loop around the disk. Others dive toward the center. They trace invisible paths through the galaxy, the fingerprints of cosmic cannibalism, still glowing after billions of years. Number 13. The Milky Way doesn't lie flat. It's slightly bent, warped like a wave frozen in mid-motion. This warp was invisible until we looked in radiolight. The hydrogen gas far beyond the stars revealed it. Why is the galaxy twisted? Perhaps because of nearby dwarf galaxies tugging at its edge, or dark matter clumps pulling from below. Whatever the cause, our galaxy is not a still plate, but a rippling sea. Number 14. Under the best conditions, no lights, no clouds, the human eye can see only about 0.00003% of the Milky Way. Just a few thousand stars. That streak in the sky is an illusion of scale. Our galaxy holds over 100 billion stars, maybe more, and most of them, nearly all of them, are invisible to us. Too far, too faint, hidden behind dust. Number 15. Stars orbit the galaxy at different speeds. The ones closer to the center move faster. The ones farther out move more slowly. This uneven rotation is why spiral arms form. They're not fixed trails of stars, but density waves, like traffic jams in the sky. As the wave moves, gas compresses. Stars form, light flares, and the spiral arms glow for a while before fading, as stars drift in and out like dancers. Number 16. By all logic, the galaxy should fly apart. The stars at the edge move too fast. They should escape, but they don't. Something holds them in, something invisible. That something is dark matter. It has mass, it has gravity, but it doesn't shine or reflect. We've never seen it directly, but we know it's there because of what it does. Without dark matter, our galaxy wouldn't just change. It wouldn't exist. Number 17. At the very center of the galaxy is a supermassive black hole. It's called Sagittarius A star. It's more than 4 million times the mass of our Sun, and yet it fits in a space smaller than Mercury's orbit. We can't see it directly, but we can watch stars whipping around it at astonishing speed. They curve through invisible loops, and sometimes matter spirals in, heating, glowing, and then vanishing forever. Number 18. The heart of the galaxy isn't round. It's shaped like a peanut or a box. When astronomers mapped the bulge in the center, they found a thick, three-dimensional hourglass of stars. This shape likely formed from the slow buckling of the central bar, a stripe of stars rotating within. Over time, it puffed upward. What seems like a smooth bulge is actually a strange, sculpted structure twisted by gravity. Number 19. The spiral arms of the Milky Way are filled with stars, but they are also stitched with clouds. These clouds, giant, dusty nurseries, are where new stars are born. When gas flows into a spiral arm, it compresses. Then gravity takes over. Clumps collapse, light ignites, and a new star is born. These arms are not just shapes, they are stories. Trails of birth and motion, written in dust and fire. Number 20. Beyond the glowing disk lies a halo, a vast, faint sphere that surrounds the galaxy. It holds old stars, globular clusters, and most of the dark matter. It's nearly invisible, but it might contain more mass than the whole bright disk combined. Stars in the halo drift slowly far apart. Some were captured from other galaxies. Others have been here from the beginning. The halo is the galaxy's memory. Number 21. We don't see the spiral arms from above. We live inside the disk, so our view is sideways, like standing in the forest and looking along the trees instead of from above. That's why it's hard to know exactly how many arms the Milky Way has, or how they curve. We rely on radio waves, infrared maps, and years of careful motion tracking to glimpse the true shape of our swirling home. Number 22. The Milky Way spins, but it also breathes. At its center, quiet now, lies a giant that once roared. Sagittarius, a star, may have once flared like a quasar, blazing across the sky. Though it sleeps today, evidence remains. Bubbles of gamma rays rising above and below, silent ghosts of ancient light. The past leaves echoes, and sometimes, even in silence, the galaxy remembers its own fire. Number 23. We live in a calm part of the galaxy. Our solar system isn't inside one of the massive spiral arms, but in a small lane between them, the Orion Spur. It's not especially bright or crowded, and maybe that's why we're here. This quiet corner may have given Earth enough time, enough calm, to let life begin, evolve, and wonder. In a lull between the storms, life found a voice. Number 24. The center of the Milky Way isn't a glowing ball, it's a bar. A long stretch of stars crossing the core, rotating slowly and reshaping the inner galaxy. Bars like this are common in spirals. They funnel gas inward, stir up stars, and help shape the spiral arms. The Milky Way is not a static design. It's a structure in motion, sculpted by gravity and time, line by line. Number 25. We're not alone in space. The Milky Way belongs to a small family called the local group, a cluster of galaxies bound together by gravity. There are more than 50 members. Most are tiny dwarfs, but two are giants, our Milky Way and the Andromeda Galaxy. And together, they form the backbone of this drifting group, distant cousins, slowly spiraling toward each other. Number 26. The galaxies in the local group are not drifting apart. Some are even moving closer. Gravity holds them in a slow dance, looping, falling, curving paths over millions of years. Some dwarf galaxies orbit the Milky Way like moons. Others roam freely, but are still tethered. Over time, this group may merge, a soft gathering of stellar islands drawn slowly inward by unseen threads. Number 27. The Milky Way's disk isn't just wide, it's layered. There's a thin disk where most young stars and gas lie, and above and below that, a thicker disk, puffier, older, more diffuse. Stars there follow tilted, elliptical paths and contain fewer heavy elements. It's a signature of a time before the spiral flattened, when the galaxy was still rough, uneven, and slowly learning its shape. Number 28. Threaded through the galaxy is a magnetic field, invisible but real. It twists and loops, aligning with spiral arms and reaching into the halo. It shapes how cosmic rays travel. It guides how gas collapses. It's faint by human standards, but over galactic distances, it matters. The Milky Way doesn't just shine with starlight. It hums with magnetism, like a faint whisper through the dark. Number 29. Between the stars is not empty space. It's filled with a thin mix of gas, dust, and plasma, the interstellar medium. It flows, curls, and folds across the galaxy like fog stirred by ancient winds. Supernova carve holes in it. Stellar winds sculpt it. It's the material from which stars are born, and into which they return. What seems like nothing is really a web of everything. Number 30. Even as you rest, cosmic rays are passing through you. High-energy particles, born in supernova and distant galaxies, stream through the Milky Way at nearly the speed of light. Most go unnoticed. But a few collide with atoms, sparking showers of secondary particles. They carry news from distant fires. They are the breath of dying stars. And every second, they touch your skin. Number 31. The Milky Way is always gathering. It doesn't just exist, it drinks. Fresh gas flows in from the vast cosmic web, the invisible strands connecting galaxies. Some of it slips in quietly. Some arrives hot, shocked, lit with ultraviolet fire. These rivers of raw material nourish the galaxy, feeding star formation. Even now, we are not sealed off. We are still connected, still sipping from the ancient veins of the universe. Number 32. When groups of massive stars go supernova, they create superbubbles, vast pockets of hot gas that rise like chimneys out of the galactic disk. These vertical channels carry energy, matter, and magnetic fields upward, venting into the halo. They regulate pressure, scatter elements, and help shape the space above. Like the galaxy is breathing, in, out, through columns of glowing gas that stretch into the dark. Number 33. The Milky Way glows in wavelengths we cannot see. In X-rays, it flares. From the core, from collapsed stars, from gas heated to millions of degrees. Binary systems with white dwarfs or neutron stars can siphon matter and create bursts of high-energy light. The halo emits soft X-rays, revealing structure beyond the stars. This galaxy isn't just starlight. It is radiation, invisible, powerful, and always in motion. Number 34. When some stars die, they become pulsars, tiny neutron stars that spin rapidly and beam radiation in perfect intervals. Like lighthouses, they flash rhythmically across space. Some rotate hundreds of times per second. Their timing is so precise, scientists use them as cosmic clocks. They measure distance, gravity, even search for gravitational waves. They are echoes of death, ticking steadily in the quiet spaces between stars. Number 35. We cannot see much of the Milky Way in visible light. But radio waves let us listen instead. They pass through dust and show us hydrogen clouds, spiral arms, and distant star nurseries. Using radio telescopes, we've mapped the galaxy's curves and warps, found hidden structures, and peered beyond the light. When we can't see, we hear. When we can't observe, we translate the sky's quiet signals into shape. Number 36. The sun probably wasn't born alone. Most stars form in clusters, groups of siblings born from the same collapsing cloud. Long ago, our sun likely shared space with hundreds or thousands of stars. Over time, gravity scattered them. Some drifted nearby. Some vanished. Some may still shine in our sky, unnoticed. If we find them, we may learn about the cradle that made us, the family we forgot. Number 37. Astronomers are searching for the sun's lost siblings. With missions like Gaia and detailed chemical analysis, they hope to find stars that were born in the same cloud, same age, same ingredients, same motion. A few candidates have appeared. These stars would help reveal what our early neighborhood was like, what the sun grew up next to, and maybe why this little corner of the galaxy became home to life. Number 38. The disk of the Milky Way wobbles. From afar, it might look flat. But when radio telescopes map the gas, a gentle warp appears. The disk is bent upward on one side and downward on the other, like a slow-motion ripple across a spinning plate. This wave may have been caused by dwarf galaxies tugging at the edges, or by clumps of dark matter pushing from below. The galaxy is dancing. Number 39. Just as the moon pulls tides on Earth, the Milky Way's gravity creates tides in everything near it. Star clusters, satellite galaxies, even globular groups feel the galaxy's uneven pull. Over time, these tides stretch and unravel them. Long streams peel off. Loops widen. These are not sudden breaks. They are slow unspoolings, quiet erosions of structure, strand by strand, over millions of years. Number 40. You might think we know the Milky Way's total weight, but measuring it is surprisingly hard. Most of the mass is invisible, dark matter in a huge, unseen halo. Estimates vary widely. Some say it weighs about 1 trillion suns. Others say much more. The outer stars are too distant, their speeds hard to track. Our home floats through space, but we don't yet know exactly how heavy it is. Number 41. The Milky Way might be heavier than Andromeda. For years, we thought Andromeda was the larger galaxy, brighter, broader, more massive. But new measurements of dark matter suggest our own galaxy's halo might be broader and denser. If true, it changes how the future merger will unfold. The Milky Way may appear gentler, but it carries more weight than we once believed. More quiet gravity, more pull, more story. Number 42. The Magellanic Clouds, 2 bright satellite galaxies visible from the southern hemisphere, may not be lifelong neighbors. For a long time, we assumed they orbited us for billions of years. But new data suggests they may be on their first close pass, just now falling under our gravitational pull. If true, their arrival is stirring our outer disk. Ripples, warps, a new guest, changing the rhythm of the room. Number 43. Trailing behind the Magellanic Clouds is a vast ribbon-like stream of gas. This is the Magellanic Stream, a long, curved filament of hydrogen stretching hundreds of thousands of light years across the sky. It was pulled away by gravity as the clouds passed each other and us. It doesn't shine in visible light, but in radio waves it appears like a whisper of motion, a trail left in silence. Number 44. Not everything in the Milky Way moves in a flat plane. Some clouds of gas, and even some stars, orbit on tilted paths, far above or below the galactic disk. These polar orbits likely began in past mergers, when galaxies collided from odd angles. the captured material continued in strange loops. They're reminders that the galaxy was not born neat. It was shaped in chaos, and it remembers. Number 45. Sometimes starbursts leave behind bubbles. In some regions of the Milky Way, astronomers have found enormous spherical shells of gas, like cavities punched into the interstellar medium. These were carved by groups of massive stars that formed together, lived fast, and died in brilliant explosions. The combined energy cleared the area. The shells remain, fossils of light, ghosts of creation and collapse, echoes of fireworks floating silently through the dark. Number 46. We often say stars never collide. Space is vast. But in the densest neighborhoods, like the cores of globular clusters, stars can pass so close they interact. Some even merge. The result might be a bright flash, or the birth of a strange blue star that seems younger than its neighbors. These encounters are rare, but not impossible. In the tightest corners of the galaxy, space runs out. Number 47. Some stars live as pairs, binaries, bound in gravitational embrace. But this bond can break. If such a pair passes near the central black hole, tidal forces can fling one star away while the other falls inward. Or a supernova may disrupt the balance, hurling one survivor outward. These torn partnerships create rogue stars, wanderers moving alone, sometimes fast enough to leave the galaxy forever. Number 48. A few stars really do escape. If a star reaches escape velocity, about 500 kilometers per second, it can leave the Milky Way behind. Some are flung outward by the central black hole, others by binary disruptions or close gravitational slingshots. These hypervelocity stars are rare, but real. They drift away into the intergalactic dark, carrying the memory of where they came from and leaving no trail. Number 49. Not all stars we see in the halo were born here. Some come from other galaxies. As the Milky Way absorbed dwarf systems over time, some stars were caught and now orbit far from the disk. Their motion is unusual, their chemistry unfamiliar. They are immigrants, cosmic travelers now woven into our sky. The Milky Way is not a closed system. It is a collage stitched by motion and time. Number 50. The Milky Way breathes, not just in the disk, but between disk and halo. Gas rises from supernova and stellar winds, forms huge fountains into space, then cools and rains back down. This cycle redistributes energy, stirs the medium, and regulates how stars are born. It's not fast, but over millions of years, the galaxy inhales and exhales. A quiet rhythm, a soft engine, a breath between birth and death. Number 51. Tiny grains of dust drift through the galaxy, but they're not just debris. Many of them carry complex carbon-based molecules, alcohols, hydrocarbons, and other organic compounds. Some were forged in the outer layers of dying stars. Others formed inside cold clouds. They're not alive, but they are rich with potential. These particles fall onto planets, mix into comets, and quietly deliver ingredients that might someday become life. Number 52. When stars and planets form, they inherit the chemistry of the cloud that birthed them. That means if a gas cloud is full of water, carbon, or organic molecules, those same ingredients might end up on rocky worlds. Across the Milky Way, some regions are especially rich in prebiotic materials. If the conditions are right, calm, warm, stable, those ingredients could seed something astonishing, or even someone. Number 53. Most stars spin, but some spin incredibly fast. Some complete a full rotation in just a few hours. These rapid rotators often have bloated equators and can fling gas outward, creating rings or glowing disks. Their lives tend to be short and dramatic, unstable, flaring, and sometimes erupting. The sun rotates slowly by comparison. These stars spin like sirens in the dark, glowing fast and fierce, then gone. Number 54. The Milky Way isn't aligned with our solar system. The galactic plane, the flat disk of stars, is tilted at an angle of about 60 degrees to Earth's orbit. That's why the Milky Way appears as a diagonal band in the sky. As the seasons change, the way we see it shifts. We are tilted inside it, a little solar system, in a big spinning city, sailing at an angle through starlight. Number 55. Some white dwarfs, faint stellar remnants, are older than the Milky Way's disk. They live in the halo, far above the plane. These stars burned long ago, then died quietly, cooling into glowing cinders. Because they formed before the disk settled, they tell us about the earliest stages of our galaxy's formation. They're not bright, but they are old, ancient embers still glowing at the edge of memory. Number 56. The farthest stars in the Milky Way don't orbit near the center. They drift in the outer halo, sometimes more than 100,000 light-years from the core. Their orbits are slow and wide, taking billions of years to complete. Many of these stars were captured from dwarf galaxies and now live at the edges. They define the size of the galaxy, not by how they shine, but by how they move. Number 57. The Milky Way looks symmetric in diagrams, but in truth, it's lopsided. One side of the disk is thicker. Some spiral arms are longer or brighter. The warp isn't even. Even the stellar halo is slightly off-center. These imbalances might come from past collisions, gravitational nudges, or uneven flows of dark matter. The galaxy is not a perfect wheel. It is a memory, twisted, bent, and beautiful in its asymmetry. Number 58. Some stars pulse like beating hearts. Their brightness rises and falls in regular rhythms. These are variable stars, and some, like Cepheids and RR Lyrae types, have a special property. Their period tells us their true brightness. That means we can measure how far away they are. These stars act like lighthouses, blinking across the void, helping us measure distance, trace the arms, and map the hidden shape of our galaxy. Number 59. One of the greatest star maps in human history is being made right now. It's called the Gaia mission, a spacecraft that's tracking over 2 billion stars, measuring their motion, distance, and brightness with incredible precision. Gaia has already uncovered streams, loops, ripples, and hidden history in the Milky Way. It's changing how we see our home, turning the fuzzy band in the sky into a living map. Number 60. When you see the Milky Way stretch across the sky, you're looking along the densest part of the disk. That hazy stripe is the galactic plane, the central layer where most stars live. It's not a line, it's a thickness, a glowing field of gas, dust, and starlight packed tight. We see it edge on, not from above. And in that line of light is almost everything: birth, fire, dust, and time. Number 61. If you look toward the constellation Sagittarius, you're facing the Milky Way's heart. From Earth, the view is blocked by dust. We can't see the core, invisible light. But in infrared and radio, it glows brightly. Even with the naked eye, the region looks more crowded. You're seeing the overlapping light of billions of stars. We live far from that center. But when we look that way, we glimpse the galaxy's pulse. Number 62. From Earth, we can't look down on the Milky Way. We're inside it. So what we see is a flattened ribbon of stars curving across the sky. That's the galactic disk, edge on. It's not curved in space. The curve is from our own horizon. Understanding the galaxy's shape required centuries of measurement, mapping, and deduction. From within, we don't see the spiral. We see only the glowing forest we live in. Number 63. Even with powerful instruments, we only glimpse a fraction of what the Milky Way contains. Dust hides stars, motion hides matter. Dark matter outweighs visible things many times over. The space between stars seems empty, but it's full of potential, of atoms, of drifting clouds. The Milky Way is larger than what we can detect. A story told mostly in hints. It holds light, yes, but also secrets and silence. Number 64. We've now passed through dozens of quiet truths about motion, about memory, about the stars that flicker and the clouds that wait. The disk ripples, the halo breathes, the arms twist and birth and fade. Even the dark carries meaning. Even the gaps between stars are not really empty. They are waiting, listening, and you are floating through it all, not just watching it, but being part of it. Number 65. Every atom in your body has passed through this system. The iron in your blood was made in a dying star. The oxygen you breathe was forged in fire. The dust of the galaxy is also the dust of you. You are part of this, not as an outsider looking in, but as a child of it. The galaxy spins, and you spin with it. You've always belonged to the spiral. Number 66. As you rest, the Earth turns. The moon drifts. The sun orbits. The whole solar system sweeps through the disk. Stars are born. Others dim. Light leaves one star and travels for thousands of years, only to end its journey in your eyes. The galaxy doesn't wait. It keeps moving. But in moments like this, we get to pause, to wonder, to float softly inside the current. Number 67. The Milky Way contains far more than we ever imagined. More stars, more systems, more movement, but also more story. A narrative written not in words, but in gravity and gas, in the slow curling of arms, in the quiet pulses of variable stars, in the spaces where stars have not yet formed, and where others have long gone dark. The galaxy is not just a place, it's a living memory. Number 68. Our place in this galaxy is ordinary and extraordinary. We're in a small spur, not in the core or the outer halo, not in a major arm, just a quiet swirl between the big lanes. But here, on one rocky planet around one medium star, the universe began to look back at itself. You, thinking about the galaxy, are proof that this place creates awareness, a spiral that dreams. Number 69. If you're still awake, take a moment. Breathe slowly. Let your thoughts drift like stars in the halo. The Milky Way is vast, but you are not lost in it. You are cradled by it. Every movement, every flare, every quiet collapse, it's all part of the same whole. You, the galaxy, the stars above, and the atoms inside. You are not apart from it. You are its echo. Number 70. There's no single shape to the Milky Way. Sometimes it's shown as a clean spiral, sometimes as a blur of arms and dust. But in truth, it's messy, asymmetrical, warped, tilted, twisted by time. It's not flawed, it's alive. Every lump and bend is part of its history. Its scars, its memories, a spiral not drawn with precision, but with love. This is our home, imperfect, beautiful, and still growing. Number 71. The center of the galaxy shines brightly in X-rays, but you don't see it with your eyes. Only special telescopes can. That high-energy glow comes from collapsed stars, black holes, and binary systems. White dwarfs pull material from their companions, heating it to millions of degrees. And in the halo, hot gas emits faint radiation. What we see in visible light is just one layer. Beneath it, the galaxy burns. Number 72. Some of the galaxy's most reliable clocks are pulsars. These fast-spinning neutron stars blink with incredible regularity, sometimes hundreds of times per second. Their signals are so precise that astronomers use them to measure time, test relativity, and search for gravitational waves. They're tiny, dense corpses of once massive stars, now turned into cosmic lighthouses. Not chaotic, not random, just ticking steadily in the silence of deep space. Number 73. To see the invisible parts of the galaxy, we use radio waves. They pass through dust. They reveal hydrogen clouds. They show spiral arms and star-forming regions hidden in darkness. Arrays of radio telescopes combine their signals to form sharper maps, mapping warps, tracking gas, even glimpsing other galaxies behind our own. The Milky Way may be mysterious, but it leaves fingerprints in every frequency. Number 74. The Sun, like most stars, wasn't born alone. It likely formed in a stellar nursery, a cluster of stars born from the same collapsing cloud of dust and gas. Over time, those siblings scattered across the galaxy. Some may still shine nearby. Others are lost to time. But the Sun remembers, and the atoms in your body may carry faint echoes of a shared beginning, a stellar family long dissolved. Number 75. Now astronomers are hunting for the Sun's lost siblings. They search for stars with matching chemistry, motion, and age. Some may still orbit nearby. Finding them could teach us about the Sun's birth environment, the radiation, the collisions, even the types of planets that formed. Reuniting the solar family could reveal not just the Sun's story, but the early conditions that made Earth possible. Number 76. The Milky Way's disk is not perfectly still. It wobbles, ripples like a spinning plate that's been nudged. That warp is easiest to see in the outer regions. The cause? Likely gravitational tugs from dwarf galaxies, or clumps of dark matter. Over time, these distortions spin with the disk. From Earth, we don't feel the wobble. But from afar, the galaxy's spin is more of a sway, slow and soft. Number 77. Galactic tides stretch and distort everything they touch. Just as the Moon pulls Earth's oceans, the Milky Way pulls on clusters and satellite galaxies. These tidal forces are subtle, but relentless. Over time, they can peel stars away, creating long, looping streams. Some structures are still dissolving. Others are already smeared across the sky. The galaxy doesn't shatter things. It unwinds them, slowly and quietly. Number 78. How much does the Milky Way weigh? We're not sure. Most of its mass is dark matter, and we can't see that directly. Estimates range from 1 to several trillion suns. The farther out we look, the harder it is to measure. Some stars move fast enough to hint at more mass than we expected. Until we can see dark matter, we may never know exactly, but we can feel its pull everywhere. Number 79. For a long time, we thought Andromeda was heavier than the Milky Way. It looked brighter, bigger, but new data suggests our galaxy's dark matter halo might be denser and wider. That could mean the Milky Way actually has more mass, even if it looks modest. When the two galaxies merge someday, that hidden weight will shape how the encounter unfolds. The quiet one may be the stronger. Number 80. The Magellanic Clouds, our small satellite galaxies, might be newcomers. Long believed to be orbiting us for ages, they may have only recently arrived. Their motion hints that this could be their first close pass. If so, their gravity is stirring our outer disk, changing the warp, creating ripples. The galaxy isn't static. New guests arrive, and even small ones can bend the shape of giants. Number 81. Trailing behind the Magellanic Clouds is the Magellanic Stream, a vast ribbon of hydrogen gas. It doesn't glow in visible light, but in radio, it stretches for hundreds of thousands of light years. This stream was pulled away by gravity as the clouds passed close to us and each other. It floats like a memory, a faint whisper stretched across the southern sky. A story told without stars. Number 82. Not all gas clouds orbit neatly. Some move in highly inclined polar directions, tilted above or below the disk. These orbits may come from captured galaxies or infalling material. The result is a layered complexity, not just a flat spiral, but a multidimensional swirl. The Milky Way contains not just planes, but ribbons, shells, and loops, strange paths born from ancient collisions. Number 83. In some parts of the Milky Way, enormous spherical shells of gas have been found. These were created when groups of stars exploded in rapid succession. Their combined force hollowed out the surrounding gas, carving vast cavities. Over time, these shells cooled, but their shape remained. They are remnants of a violent past, fossilized firework echoes, still expanding slowly into the cold. Number 84. Stars are small. Space is huge. So stellar collisions are rare, but not impossible. In the dense cores of globular clusters, where stars crowd close, some do pass near enough to interact. They may merge. They may spark brief outbursts. Sometimes they form blue stragglers, stars that seem too young for their surroundings. In these crowded neighborhoods, the stars aren't just points. They're dancers with close steps. Number 85. Binary stars, pairs that orbit each other, can be pulled apart. If they pass close to the central black hole, tidal forces can tear them loose. One may be captured, the other flung into the void. Some binary systems are disrupted by supernova. These breakups can create rogue stars, high-speed escapees, racing away from the galaxy. They were part of something. Then, suddenly, they were alone. Number 86. Some stars reach escape velocity. That means they move fast enough to leave the Milky Way forever. A few are thrown out by the black hole at the center. Others are slingshotted by three-body interactions or binary explosions. Once free, they drift into intergalactic space, unbound, untethered. They become solitary beacons, carrying the Milky Way's light outward into the long dark. Number 87. The Milky Way is a collector. It holds stars that came from other galaxies, captured during past mergers, flung into the halo, now orbiting in strange paths. Their motion and chemistry reveal their origin. Some are far out, others pass close. They are not imposters. They are adopted stars, immigrants folded into our galactic family, shining with memories from somewhere else. Number 88. Gas doesn't just rise from the disk. It falls back too. This cycle is called the galactic fountain. Supernova heat gas, pushing it into the halo. There, it cools, condenses, and drifts back down, sometimes to a different region entirely. This circulation mixes elements, spreads energy, and keeps the galaxy active. Like breath, the Milky Way inhales and exhales, slowly, across millions of years. Number 89. Dust carries molecules, and some are organic. Inside interstellar dust grains, we've detected carbon chains, alcohols, sugars, and more. These aren't living, but they're the building blocks of life. They form in dying stars or cold clouds. They drift between systems. Some fall onto planets, some seed comets. The galaxy is not just stars and light. It's chemistry, potential, and the quiet hope of life. Number 90. When stars are born, their planets form from leftover dust and gas. That means the chemistry of the birth cloud matters. If the cloud is rich in water, carbon, or metals, the planets may be too. That inherited composition could influence what kinds of worlds form and whether they're habitable. The ingredients for life may not be rare. They may be everywhere, waiting for warmth and time. Number 91. Some stars spin incredibly fast, hundreds of times faster than the sun. These rapid rotators can become a blade, throwing off material that forms glowing disks. Their speed creates instability. They brighten, dim, pulse. Some live short, dramatic lives. These aren't quiet suns. They're cosmic sirens, singing bright and wild, and then vanishing before the spiral even notices they were gone. Number 92. The Milky Way's disk is tilted relative to the ecliptic, the plane of our solar system. That's why the galaxy appears to sweep diagonally across the sky. It's not flat overhead, it leans, and that angle shifts with the seasons. From Earth, we trace the disk as a tilted ribbon. We don't just spin inside the galaxy, we spin at an angle, a tilted boat in a cosmic current. Number 93. In the halo, some white dwarfs are older than the disk itself. These stellar remnants lived and died before the spiral took shape. They glow faintly now, cooling over billions of years. Their presence hints at a deeper history. Before arms, before warps, before bars. Just scattered stars, and gravity's slow weaving. These white dwarfs are not bright, but they are witnesses to the galaxy's earliest hours. Number 94. Some stars orbit at astonishing distances, well beyond the spiral arms. They take billions of years to complete a single loop. They drift through the outer halo, like distant scouts, thin, faint, and quiet. Many were likely captured long ago, their orbits stretched by time. They don't add much light, but they mark the boundary of the Milky Way's reach, the last stars before the long night. Number 95. Even after all this, we're still mapping, still discovering. The Milky Way isn't just big. It's layered, breathing, moving. Its arms are not lines. Its shape isn't still. Its heart holds silence. Its halo holds memory. And somewhere, on a small planet orbiting a quiet star, you heard its story. And maybe tonight, you'll dream not of sheep, but of galaxies, of drift, of starlight, of where you already are. Number 96. The Milky Way is still eating. Tiny galaxies fall into it, sometimes barely noticed, like drops in an ocean. Their stars join our halo. Their gas fuels new suns. These mergers don't just build mass. They stir the disk, ripple the arms, and change the path of stars already here. Our galaxy is not finished. It is still stitching itself together, one swallowed fragment at a time. Number 97. We live in a cosmic suburb. The solar system lies far from the crowded galactic core. Out here, things are quieter. Fewer stars, less radiation, less chaos, and maybe more opportunity. In this peaceful corner, Earth had time to cool, stabilize, and grow life. If we were closer to the core, we might never have emerged. Sometimes distance is not separation. It's protection. It's the space where stories can begin. Number 98. The sun bobs up and down as it orbits. Its path isn't flat. It rises above the disk, then dips below, then rises again, like a cork floating on a wave. This motion is slow, tens of millions of years per cycle. Some have wondered if these crossings affect Earth, maybe triggering extinctions, maybe not, but it's real. The sun doesn't just spin around the galaxy, it gently sways through it. Number 99. Some parts of the Milky Way are incredibly quiet. Vast clouds of gas that never collapsed into stars. These starless regions are full of potential, cold, dense, and untouched. Maybe one day they'll be nudged, compressed, and set alight. Or maybe they'll drift quietly, waiting forever. In these clouds, the galaxy holds its breath. Not everything shines, but everything might. Number 100. In the dark between stars, magnetic fields swirl. They guide dust. They shape how particles move. They even polarize light, making it bend, twist, flicker differently. We can't see these fields, but they are everywhere, tracing spiral arms, threading clouds, whispering through the halo. The Milky Way glows in light, but it dances in magnetism. Number 101. Gravitational waves pass through us, faint ripples from faraway collisions. When black holes merge, the universe shakes, not loudly, not quickly, but deeply. Space itself stretches and compresses. We can't feel it, but we can measure it. The galaxy is filled with these echoes, slow, soft shivers in the fabric of reality, like a sleeping giant turning gently in its sleep. Number 102. The galaxy has rings, invisible ones, not like Saturn's. These are made of stars, loops left behind by disrupted galaxies. As they fell in, they wrapped around the Milky Way, their stars following long curved orbits. Some are still visible in maps. They're not obvious, but they're real. The galaxy wears them like forgotten jewelry. Traces of old dances it doesn't remember starting. Number 103. Even dark matter might not be still. Some models suggest it could clump, ripple, or flow, forming hidden structures in and around galaxies. We can't see them yet, but their effects may be there, in the way stars move, in the way galaxies collide. If true, then the galaxy isn't held together by a quiet halo. It's wrapped in a living storm of something we still don't understand. Number 104. Some globular clusters orbit backward, against the spin of the disk. These ancient star clusters were likely captured from other galaxies, too old, too metal poor, too oddly placed to have formed here, but they remain, circling the Milky Way on retrograde paths. Like elders with memories of other homes. They didn't begin here, but now they are part of our sky. Number 105. The Milky Way is a spiral, but spirals don't last forever. Over time, galaxies evolve. Bars grow longer. Arms fade, disks thicken. Cores flare, and then sleep. Someday, billions of years from now, our galaxy may look very different. It may merge with Andromeda, warp into a new shape, or settle into quiet stillness. But tonight, as you rest beneath its arms, it is still turning, still beautiful, still ours.